so this is recapping from yesterday. Again, since some of y'all didn't get it completed for whatever reason. So again, the radians and degrees around the unit circle need to be filled in. This is a refresher from before Thanksgiving break. We had filled it a full circle in. We had actually done them part by part. We had done it by all the 60s and by all the 45s and then by all the 30s. Okay, and then we had put it all together in our last set of notes as well. Okay, so remember, I just pointed out the pattern for degrees. If to fill in degrees, you can do plus 30, 15, 15, 30. Okay, so starting at 0, plus 30, plus 15, plus 15, plus 30. And then do it again, plus 30, plus 15, plus 15, plus 30. And that's one way to go around and get all of your degrees filled in, is using that pattern. Okay, and then the radians, you've got to know at least this quadrant 1. If you can get this quadrant 1, that will help you fill in the other quadrants, because all of these that reflect over will have this, like this is pi 6th, because it's a 30 is a 1/6 of the way to 180. 180 divided by 30 is 6. Okay, but all of these that are highlighted in yellow, okay, mirror that. So they're all a 6th denominator. Okay, but it's how far you are from the x-axis. So if pi is 1 full, that'd be 6/6 pi. And so this is 1 less, so it's 5/6. Or this is 1 more, so it's 7/6. Or from 2 pi in 6, that would be 12/6. So this is 1 less, so it's 11/6 pi. Okay, so again, that's review from before the break. All right, so then the next step, what you did in the notes yesterday was review special right triangles, the 30, 60, 90 triangle and the 45, 45, 90 triangle, to get the values for these coordinates, these ordered pairs around the unit circle. I'm going to zoom in on this. So let's look at, actually, before we look at those, let's just look at the quadrantal. So if I'm on the x-axis, tell me again, what's the radius of the unit circle? So what would this coordinate of this point be? 1, 0. I went over 1, up 0. That's the xy coordinate. Okay, what about this point at the top of the circle? Yeah, I went over 0, up 1. Okay, and this point on the left edge. Okay, and the one on the bottom edge. Good. Okay, now you went through the notes yesterday and did 30, 60, 90 right triangle and 45, 45, 90 right triangle, and came up with the distance, the horizontal distance and vertical distance to get to this coordinate. If this is 1 unit long, if this is on the unit circle, this radius is 1, how far over and up do I have to go to get to this point? And using those ratios, we came up with square root of 3 over 2, 1/2 for a 30-degree reference angle. Okay, so we have to go over root 3 over 2, up 1/2. Okay, and then we talked about the 60 is just the inverse of that. You just switch the x and y because it's still a 30, 60, 90 triangle. It's just flipped around so that the short edge is on bottom horizontal and the long side is vertical. So the x and the y just switched so that x was 1/2, y was root 3 over 2. And at the 45, you have to go over and up equidistant because that's an isosceles triangle if it's a 45, 45, 90. And to get those values we came up with, they were square root of 2 over 2, square root of 2 over 2. Okay, so those were found on the notes from yesterday. If that's confusing you, if you haven't taken the notes from yesterday or watched that video, go back and do that. You'll understand where those numbers came from better. Now, then we said, okay, just like the reference angles match up, how I've color coordinated them, like the yellows are all 30-degree reference angles, the coordinates are going to match up. Because if I want to get to this point on the circle versus this point at 150 degrees, I have to go the same distance over and up, right? It's just in a different direction. It's left and up instead of right and up. Do y'all agree? So the distance doesn't change. The numbers are still √3/2 and 1/2. How do I notate that the direction is different though? Yeah, I went left. That's the X value that needs to be negative. So we just need to make the X negative. The Y is still positive because I still went up. Agreed? Okay, so the same thing's going to happen at the 45 and the 60 reference angles here that match up. Everything's going to be the same except the X is negative because when I'm plotting a point in quadrant 2, left and up, that's negative, positive. So X is negative, Y is positive. But we can go ahead and fill the numbers in because they match what we came up with in quadrant 1. Okay, same thing applies for the bottom half of the circle in quadrants 3 and 4. Okay, except now in quadrant 3, not only am I going left, which is a negative movement, I'm now going down, which is a negative movement. So here in quadrant 3, it's both the X and the Y that need to be negative. We need to put a negative in front of all of the X's and Y's in this quadrant. But the numbers don't change. The 30-degree or the pi/6 reference angle is still going to be √3/2 for the X and 1/2 for the Y. It's just the negative getting tacked on. This is still going to be √2/2 for the X and the Y. This one will be the 1/2 √3/2. Now in quadrant 4, what should be positive and negative here? Yeah, just the Y is negative because I'm going to the right and down. So X is positive, right is a positive movement, down is a negative movement. So just the Y is going to be negative. But again, the values stay the same. √3/2, 1/2. √2/2, √2/2. 1/2 √3/2. So far, so good. Does that make sense? So everything on your unit circle inside the degrees and radians, and now the coordinates should all be filled in. So you have a few blanks left. Oops. The only blanks you should have left here is where it says tangent around the outside of the coordinates. And then in each coordinate, each quadrant, it has a place for the quadrant, and it says positive or negative. Okay. Let's go ahead and y'all should be able to fill in the quadrants. Maybe you already have. What quadrant is this? Yeah, we start top right is quadrant 1. That's where everything's positive, right? Okay, and then this is quadrant 2. Yeah, we go in the positive rotation, which is counterclockwise, and that's how we count the order of our quadrants. So 3 and 4. Okay, so go ahead and knock those blanks out. All right, now, before I can get into tangent and fill this in, we've got to understand a few things. So we've got to kind of refresh our memory on some items from before the break, from the last unit. Okay, because we're still using that, building off that trig that we were doing on the coordinate grid. Okay, and the right triangle trig we did the unit before that. Everything's kind of just building on each other. Okay. So on the back of your unit circle, if you want to write any of this, you can. It's not I'll tell you for sure what you need to write. This part right here, not so much. But this that's boxed in red here, when we get to that, you definitely are going to want to write that. So I just want to refresh your memory real quick. Before the break, if I was given something like this, sine of theta equals 1/2 and tangent of theta is less than 0. If that was my given information, those two pieces, the process we went through, and this is what you tested on, was to first determine what quadrant you would be in based on the fact that the sine is positive and this tangent is negative. That's less than 0 means negative, and this 1/2, there's no negative, so it must be positive. Sine is positive in quadrants 1 and 2. Okay, remember all students take calculus. Okay, and tangent is negative in 2 and 4. So the overlap where both things are true is happening in quadrant 2. So we drew a triangle in quadrant 2 and we labeled with what was given, the 1/2. Remember, sine is y over r. So the y value, the vertical distance is 1, and r, here, the radius of the circle, if this is a point on the circle, is 2. Okay, and then we did Pythagorean theorem to find the third side. Now we happen to be in quadrant 2, so we knew that our x should be negative. When we took the square root, you do positive or negative. If it's r, it's always positive, but if it's x or y, it just depends what quadrant you're in. And in quadrant 2, x is negative. So we did that, and we said, okay, well, we have all three sides. Now I could give you any trig ratio, right? I started with sine, but now I could tell you cosine, secant, cosecant, tangent, cotangent, right? Now that I have all three sides and I know what quadrant I'm in. Okay, so that's what we were doing before. And even before that, what we were doing was using right triangle trig. If I knew sine of theta was 1/2, I could find theta, the missing angle, right? By doing inverse trig. Y'all remember that? I move sine to the other side, it becomes inverse sine of 1/2. And I plugged this into the calculator. And I'm telling you, if you plug that in and you're in degree mode, it comes out to 30. Okay, so both of those things are kind of refreshers on some trig that we've done so far. Now, what I want you to notice is that when we go back and look at, so this is saying sine of theta is 1/2 when theta is 30. So at 30 degrees. So what that means is this angle in this picture here, if sine is 1/2, this angle must be 30, right? So if I go find that on my unit circle, the 30-degree reference angle in quadrant 2, okay, the 30-degree is the yellow. Okay, at this reference angle in quadrant 2, where do you see a 1/2 as the y value? Does everybody see that? That's because on the unit circle, what's the radius? What did we say this radius is?
1.
1. So if I think about this and I say, okay, on this example, the radius was 2. This was twice as big as the unit circle, right? If I cut that in half to 1, what would that cut this in to? To 1/2, right? If I'm halving both of these, this would become 1 and this would become 1/2. And then y is 1/2, r is 1. And you don't divide by 1, that doesn't do anything, right? So we would just leave it as 1/2. So notice the y value is the sine value if you're on the unit circle. So that's where this boxed in red portion comes in. You definitely need to write this if you didn't write the other. When you are on the unit circle, this is only when you're on the unit circle. Those x and y coordinates of the points on the edge of the circle, those correspond to these trig values. X is the cosine value at that angle, whatever angle you're looking at. Y is the sine value of that angle that you're looking at. Okay, remember that it's alpha order, alphabetical. A lot of people get this mixed up and they want to say sine, cosine, because that's the order we're used to writing sine and cosine in. We usually write sine first. Okay, but this is alphabetical order. X comes before Y, C comes before S. So X corresponds to cosine, Y corresponds to sine. Just like when we were working within different quadrants before the break, we said cosine's ratio is X over R, right? And sine's ratio is Y over R. If you're on the unit circle, what is R? I know, but what's the value? If you're on the unit circle, what's the radius of the circle? 1. So if I put X over 1, that's just X, isn't it? So that's why cosine is X. Okay. If I put Y over 1, that's just Y. Sine of theta is the Y value when you're on the unit circle, because on the unit circle, R is 1. Y'all with me on that? So what that means is I can any angle. So I want you to write down these examples, and we may have time for some more, but we're going to start with these. If you're asked for sine or cosine of an angle, and it's an angle on the unit circle, it doesn't matter if it's given in radians or degrees, as long as it's an angle that you've filled in on the unit circle, you should know the answer by looking at your circle. So for instance, sine of 60 degrees. I'm going to look at my unit circle. I'm going to find 60 degrees. So where is 60 degrees on here? What quadrant? Okay, quadrant 1, it's the green one, right? 60 degrees. So at this angle, what is sine? I know the ordered pair. Which one of those did we say corresponds to sine? The Y value. So at 60 degrees, the Y value is root 3 over 2. So sine at 60 degrees is root 3 over 2. That's it. That's your answer. If you know how to read your unit circle, these start coming very, very quickly. Cosine at 3 pi fourths. So I'm going to find 3 pi fourths. Where's 3 pi fourths? Second quadrant here in blue, right? It's the 135 if you're in degrees. So at this angle, what is cosine? Yeah, negative root 2 over 2, because it's the X value. Cosine is the X. Sine is the Y. So cosine of 3 pi fourths is negative root 2 over 2. Now, these get a little more complicated. Cosine at negative 120. Negative 120 is not written on our unit circle. We only wrote the positive angles for one revolution, right? But remember, we can find the coterminal angles. We can go in the positive direction more than one revolution, or we can go in the negative direction, right? So you have to think back to rotating in the negative direction. So if I'm starting at 0, I'm going to go negative 120. Remember, one quadrant is 90 degrees, isn't it? So that's negative 90. So negative 120 is going to put me here at 240. Do you see that? Notice positive 120 is up here. Negative 120 is its reflection down here. So I went negative 120 degrees, and that puts me here at its coterminal to 240. Do y'all agree with that? Okay. So at this angle, I already forgot what it asked for. Did it ask for sine or cosine? What is cosine here? Yeah, it's the X, negative 1/2. If you need to make a note for the fact that this is notes, you may want to comment or mark here that negative 120 was coterminal with 240. So we looked at 240 on the unit circle because those are coterminal. Okay. All right. Sine of 8 pi. 8 pi is definitely not listed on our unit circle, but can we rotate around until we get to 8 pi? Okay, so let's look at our unit circle. Okay, what is a full circle in radians? 2 pi. So if I go another full circle, I'm at, and then another full circle, well, 6 pi, and then another one, 4 pi. So it's 4 full rotations, but it gets me back here to this same point. So it's coterminal with 2 pi, isn't it? Okay, so at this angle, at 2 pi or at 0, it's coterminal with both of those. What did it ask for? Sine? What is sine here? Sine is 0. Sine is the y value. So your answer is 0. So that's another one. If you want to mark, it's coterminal with these angles. So if it's a negative angle or an angle bigger than 2 pi or 360, just figure out where it is, where it's coterminal. Where does it stop? So far, so good? Okay. So now that you understand that x is cosine and y is sine, we need to figure out what tangent is to fill in these tangent values. Okay, so you may or may not remember way back when we started reviewing our trig. So I do want you to write this down. This is another one on the back I would star. We said that tangent is sine divided by cosine. Anybody remember that? In terms of x, y, and r, more recently, we said tangent is, in terms of x, y, we wrote over here, cosine is x over r, sine is y over r. What was tangent? Y over x, because sine is y, cosine is x on the unit circle, right? So I can take my y divided by my x, or my sine divided by my cosine. Okay, so that means we need to find these tangent values around the unit circle. So I'm going to start basic. I'm going to start with 0. I'm on the x-axis. So you can look at your unit circle and say at 0 degrees, I need to know sine and cosine. So at 0 degrees, it's sine and cosine, or y and x. So it's 0 divided by 1, right? Y'all agree? What is 0 divided by 1? Yeah, 0 divided by anything is just 0. So I can fill that in on my unit circle. So tangent is 0. Oh, nope, I wrote that in the wrong spot. Don't do that. We set it 0. Can you look at your unit circle and tell me where else tangent must be 0? At what other angle? At 180 or pi, because that would again be 0 divided by -1. Still be 0, right? Okay, what about at 90? What do y'all think? Is that the same? It would be. Very good. It would be undefined. So tangent at 90 degrees is not 0 over 1, it's 1 over 0. You cannot divide by 0. That is impossible. If you try to do that in your calculator, you get an error because it doesn't exist. That value does not exist there. It is undefined. And I'm going to abbreviate undefined as UND, undefined. So at 90 on my unit circle, tangent is undefined. Where else would tangent be undefined? Good, at the very bottom. Because it would be -1 divided by 0. Still can't divide by 0. Doesn't matter what the numerator is. So we've got 0 and undefined. Now we need to look at these special angles, the 30, 45, and 60. Okay, so at 30 degrees, y divided by x, or sine divided by cosine. That's 1/2 over root 3 over 2, right? Y'all agree? What do we do when we divide fractions? Yeah, flip and multiply. Dividing fractions is easy as pie. Flip the second and multiply. So we're going to multiply by 2 over root 3. And what's going to happen to those 2's then? And so I have 1 over root 3. Do we leave answers with radicals in the denominator? No. And if you watched the video for the last lesson, you saw I reviewed rationalizing. We multiply by the radical in the denominator to get rid of it. And you have to do it to the numerator and the denominator. So in the denominator, that comes out to just 3. The whole point of that is to get rid of the radical and just be left with the number underneath. In the numerator, 1 times root 3 would just be root 3, right? So root 3 over 3, that's tangent at 30. So I'm going to put that on my unit circle. Tangent at 30 is root 3 over 3. Okay, now I'm going to go ahead and jump to 60. I'm going to come back to 45. At 60 degrees, it's just the reverse of this, isn't it? Instead of 1/2 over root 3 over 2, don't I just flip it to root 3 over 2 over 1/2? If you understand that you're just switching the x and the y, you'll understand that these are reciprocals of each other. So you just take the reciprocal of what we had over here, which was 1 over root 3, and what's that going to come out to? It's just root 3. If you don't see that right away, we actually flip and multiply and simplify. So we multiply by 2 over 1, and the 2's reduce. And I'm left with root 3 over 1, which I don't have to put over 1 because dividing by 1 doesn't do anything. So it's just root 3. So root 3 and root 3 over 3 are reciprocals of each other. So that's tangent at 60 is just root 3. Now, I'm not even going to, actually I will. I was going to say I'm not going to make a note of tangent at 45 because it's pretty easy, but just so you can see it. It doesn't look easy if you set it up. Root 2 over 2 over root 2 over 2. But if you think about that, aren't those the exact same numbers, the x and the y? And anything divided by itself is 1. So at 45 degrees, tangent is simply 1. Now, we can reflect those into the different quadrants the same way that we did with sine and cosine, but let's take note of where tangent would be negative. So here in quadrant 1, it was positive because the x and the y were both positive. In quadrant 2, it would be a positive divided by a negative. What would that leave you with? A negative. So tangent needs to be negative in this quadrant. And we knew that because all students take calculus. We knew tangent was negative in quadrant 2 already, if you remembered that. Okay, but I still reflect those numbers over. So in the middle, it's still just 1, but it's negative 1. Okay, and up here, it's negative root 3. Here, it's negative root 3 over 3. So far, so good? What about in quadrant 3? X and Y are both negative. So what happens when you have a negative divided by a negative? Yeah, tangent comes out positive. And we knew that. All students take, the T is for tangent. Tangent is positive here. So it's root 3 over 3, 1, and root 3. Quadrant 4. Sine is negative, cosine's positive. A negative divided by a positive is negative. Tangents should be negative in this quadrant. But the numbers are the same. Root 3 over 3 here, 1, and root 3. Okay, so now the only thing left on your unit circle here are these positive or negative blanks by the quadrants. This is a place for you to write what trig functions are positive and negative in each of those quadrants. So I'm going to start with quadrant 1. Here we have cosine, sine, and tangent. All of those are positive, aren't they? And we knew that because of all students take calculus. So if you want to write that to help you remember, all students take calculus. You can put that on here. You don't have to. But all of them are positive. And I'm not going to write all of them out. I'm just going to write the word all. And for negative, I'm going to write none. All of them are positive here. None of them are negative. In quadrant 2, what was negative in the coordinates? Is that the cosine or the sine? That's negative? Yeah, negative is the cosine. Sine is the one that's positive. Because remember, all students, the S is for sine. Sine is positive here. It was in the ordered pair. It's the cosine that's negative, which means when those are different, tangent must be negative, right? Now, the reciprocal functions. Cosecant is the reciprocal of sine. When sine is positive, cosecant is positive. So when cosine is negative, secant is negative. When tangent is negative, cotangent is negative. Still with me? All right, quadrant 3. Both sine and cosine were negative, which meant they're the same. So when you divide them, you get a positive. So tangent's positive, which means cotangent's positive. But sine and cosine's reciprocals would be negative. And then in quadrant 4, cosine is the positive, which means secant as well, which means all of the others are negative. So sine and its reciprocal, tangent and its reciprocal. Okay, so your entire unit circle is now filled in. Do y'all have questions so far? Okay, so I'm gonna make, hang on, don't put it away yet. I was just asking if you had questions. Let's do a couple maybe tougher than just the sine or cosine ones we did a second ago. So what if I want tangent of negative pi thirds? Where would negative pi thirds be? What is that? That it's in the negative direction, so I don't see it listed on the unit circle, but what would it be coterminal with? Yeah, at 5 pi, positive 5 pi thirds or 300 degrees. I went negative 1 pi thirds. So at this location, what's tangent? No, tangent. Just negative root 3.
Oh, yeah.
Yep. All right. Y'all are going to have a bunch of this to practice tomorrow. Have a good lunch. I'm going to finish. I'm going to do like 1 or 2 more on this video just for the sake of people reviewing. I'll just be doing practice over this in class tomorrow. All right. Now a reciprocal. If you wanted to do a reciprocal, you could do that. So if I want cosecant at 135 degrees, I would have to go to 135 degrees, which is in quadrant 2. Okay, and I can see cosine, sine, and tangent, but I don't see cosecant. I have to remember that cosecant is the reciprocal of sine. So sine is root 2 over 2. The reciprocal of that would just be root 2. Okay, so the same way root 3 over 3 and root 3 were reciprocals of each other. Root 2 over 2 and root 2 are reciprocals of each other. Okay. So if you're asked for one of the reciprocal functions, you find sine, cosine, or tangent, and then you flip it. Okay. All right. So I'm going to stop that video there.
You want me to take the test on